Hello, how is everyone doing? Today we're going to be working with limiting reactants and percentage yield worksheet, which you will find on your Google Classroom. So if you don't have that up, just stop the video and get your sheet of paper. You'll need a calculator and your periodic table, a writing utensil and some paper. So let's get started. Remember, a limiting reactant is it's a reactant that is going to limit what your product is going to be. So I'm going to consider, this is the first one on here, consider the reaction where you have diiodide, I guess iodine 5 oxide, plus carbon monoxide yielding carbon dioxide plus iodine gas. And the question for letter A is to determine the amount of iodine that is going to be produced. Since it's a limiting reactant, we have to utilize both of the numbers they gave us, but in two separate stoichiometric equations. So for letter A, and I'm going to be moving this a little bit, so bear with me. If you have it out, you should be able to see it. For letter A, I'm going to start with the 80 grams, because that's the first number they gave me. That's always a good way to start. Of the iodine 5 oxide. And I'm going to do stoichiometric calculations to determine how much carbon monoxide, I guess, if it's going to be carbon monoxide or that iodine 5 oxide, which one's going to be the limiting. But I want to figure out how much iodine gas I'm making. So I go to my periodic table and I find the molar mass of I2O5. If you don't remember how to do that, please consider stopping the video and reviewing that skill. When I determine the molar mass of iodine 5 oxide, I get 333.80594 grams of iodine is 1 mole of iodine iodine 5 oxide. Looking at my balanced equation, I know that 1 mole of the iodine 5 oxide produces 1 mole of iodine gas. And 1 mole of iodine gas is 253.80894 grams of iodine. Okay, now I'm going to math it. Let's recall how to math it again. If it's in the numerator, you multiply, and if it's in the denominator, you divide. So I'm going to take 80 times 253.80894 divided by 333.80594. And I'm going to obtain a number that I have to be cognizant of the number of significant digits. So when I get my number, it's going to be 60.8 grams of iodine to the correct number of significant digits. Remember, we always use the correct number of significant digits when we answer our questions. In the middle, we use what they have in the periodic table, but when we get to that final answer, we look at our original problem and determine how many significant digits we need. Now that's how much iodine gas can be made from iodine 5 oxide. At any time, if I'm going too fast or if you need to just review something, please stop the video and do that. The next thing we're going to do is we're going to take the 28.0 grams of carbon monoxide and we're going to change it into the iodine gas. We're going to see how much iodine gas the 28 grams of carbon monoxide is going to produce. I'm going to put my paper up a little bit so you can see this. Again, I'm going to use my periodic table and I'm going to determine the molar mass of carbon monoxide, which is 28.0101 grams. That's in 1 mole of carbon monoxide. Then I'm going to go to my balanced equation and I look at my balanced equation and I see that 5 moles of carbon monoxide make 1 mole of iodine gas. This is the ratio that transitions us from what we know, what we're given, to what we want to find out. And again, 1 mole of iodine gas is 253.80894 grams of iodine. Okay, so let's figure that. We'll do some mathing on that. If you want to stop that video and math it out and see if you get the right answer, that would be a good practice. As I math it out, I'm going to take 28 times 253.80894 divided by 28.0101 divided by 5. And I'm going to get something like 50.7 grams of iodine gas. Again, I'm going to write that answer to the correct significant digits. So I look at this, I'm thinking, all right, which one is my limiting reactant? Well, which one produced the least amount of product? The iodine. This is the least amount of iodine gas, so therefore, therefore I'm going to use is 3 little dots. Carbon monoxide is the limiting reactant. Please remember that reactant and reagent could be interchanged in this conversation. And 50.7 grams is the theoretical yield. This word is very important, theoretical yield. Theoretical yield indicates what should happen if everything is perfect. If all the product is going to stay in your container, you didn't lose any on your stirring rod, if nothing is being splattered because of heating too fast, that's your theoretical. That's what you're hoping if everything goes perfectly in your lab. So we looked at letter B. However, if in the above situation only 1.160 moles of iodine was produced, they ask us, okay, what would that mass be? Because we have mass here, so we want to figure out what the mass is. So I'm going to take my 0.160 moles of iodine, like they say for letter I, what mass of iodine was produced, and I'm going to change that to mass. So we're going from moles to mass. And 1 mole of the iodine, again, is 253.80894 grams. I'm going to math that, and I'm going to get 40.6 grams of iodine was produced. So as you can see, what was produced is not what we got. So scientists want to figure out, okay, if that's the case, what is my percent yield? Percent yield is like what you get on a test. How much did you get? What was your percentage based on what you got out of the total amount of points? So in the second portion of this, you take what is produced divided by your theoretical yield times 100, and you will get what is called percent yield, percentage yield. So I take what was produced, which was 40.6 grams. So let me move up my paper a little bit more. Divided by what I should have gotten was 50.7 grams times 100. And when I math it using the correct number of significant digits again, I'm going to get 80.1% yield. Please realize that this is very important when we are working in industry of any sort. If our yield is down, we will need to find better procedures to increase our yield. If we have too much of a reactant, as we do in this iodine 5 oxide, how can we reduce that amount that is going to be necessary and for cost effectiveness? So this has a practical application in everyday life. Again, please stop the video as needed, and I hope this assists you in completing this assignment.